So welcome to part 2 of lessons 4 and 5. Lessons 4 and 5 are really focusing on non-right angle triangles. So we said yesterday that there were 3 tools we could use with acute or obtuse triangles. We could use the sine law, the cosine law, as well as the fact that the sum of all the angles in a triangle equal 180 degrees. So last time we looked at the sine law. Remember, there was one condition for sine law. You needed to have an angle as well as its opposite side. So you needed an angle side pair. It didn't matter which the angle side pair was. As long as you had one pair, you could use the sine law. What we're going to focus on today is the cosine law. So again, here we have our triangle. Let's call it triangle A, B, C. So again, the A, the B, and the C represent the vertices, and the opposite side will be named the same letter, but just in lowercase. So we have capital A here, so lowercase a here, capital B, lowercase b, and capital C, lowercase c. Using this triangle, again, here I've depicted an acute triangle. This works just as well for obtuse triangles. We essentially have the cosine law. There's 2 different forms of the cosine law here. There's this form and this form. What you'll notice is that this and this are pretty much identical, except for you've isolated for different parts of the equation. So here, if you take this equation and isolate for c squared, you'll end up with this. If you take this equation and isolate for cos c, you'll end up with this. Regardless, we always want you to remember these 2 forms because they have specific purposes. If you are using this form, essentially you're trying to solve for c. So here you are isolating for a side length. So if you're trying to find side length c, this is the formula that you want to go with. If you're trying to solve for angle c, this is the formula that you're going to go with. So this is for isolating a specific angle. The general rule that we are going to follow to make our lives easier is always make the given angle C. So what does that mean? In this question, if they say that a specific angle of this triangle is 45 degrees, that angle will always be your C. So you're just going to rename that angle C, and that makes it so much easier to use this equation. Similarly, if there's an angle you want to solve for, again, call that angle C. So if you want to solve for an angle or if you're given an angle, always call it C, because in both of these formulas, capital C is that angle, is associated with the angle that we're putting into this formula. So conditions to use this law, you're going to be given 2 sides and the angle in between, or you'll be given all 3 sides. Regardless, what you won't be given is you won't be given any sort of angle side pairs. Why is this important? Remember, I said if you're given an angle as well as its opposite side, we can use the sine law. Whenever you're not given an angle and its opposite side, you will use the cosine law, which means you're either in a situation where you're given 3 sides or in a situation where you're given 2 sides and the angle in between. So I'm just going to repeat that. When you have an obtuse or acute triangle, so a non-right triangle, always check for an angle side pair. If there is one, you can use sine law. If there isn't one, you're going to use cosine law. Okay, so exercise. Solve for the indicated variable. Justify which trigonometric tool that you can use. Again, in this question, I've given you a series of questions that you should think about before using any of the formulas. In future questions, you need to think about these questions in your head so that you choose the appropriate tool. So here it says, solve for side length C. What type of triangle is this? Should always be your first question, because if you have a right triangle versus a non-right triangle, there are different tools that you can use. Here, I can see that This angle is 37. I don't know what it is, but it looks acute. And this angle looks more than 90 degrees. So I have an obtuse triangle. And now I have to decide which tool I can use. Again, with non-right angle triangles, I have three tools. I can use the sine law. I can use the cosine law. And I can use the fact that all three angles will add up to give me 180. If I take a look here, I have to first determine if I have a side angle pair. Why? Because if I have it, I can use the sine law. So before I do that, I'm just going to name all my sides. So this is capital A, so this must be lowercase a, and this is capital B, so this must be lowercase b. So I'm going to first look for angle side pairs. If I take a look at A, I don't have the angle. If I take a look at B, I don't have the angle. C, I do have the angle, but I don't have its opposite side. So I have no angle side pairs, which means I'm going to use the cosine law. Okay, and why, again, no angle side pairs are given. Remember what I said. Any angle, so that's the specific rule I said here, always make the given angle C. In this case, the given angle, the only angle that was given is C, so we are good. So here it says solve for side length C. I take a look at my equation. Remember, there are two versions of the equation. This first one, if I'm solving for a side length. This second one, if I'm isolating for a specific angle. In this case, I want to solve for this specific side length. So I'm going to go with this equation because it says solve side length C. Because my angle is already capital C, there are no changes I need to make to this equation. We'll see when we need to change the equation in a later question. So I'm going to just copy down that equation. C squared is equal to A squared plus B squared minus 2AB cos C. Once you write this equation, all you're going to do is you're going to substitute in the values. So C is what I want to solve for, so I'm going to keep it as C squared. The A is 8, so 8 squared. Don't forget, when you're substituting variables for numerical values, you want to keep them in brackets. Plus B is 11 squared, minus 2A is 8, B is 11, cos, and C, which is the angle, 37 degrees. I can simplify this using numbers I know. So 8 squared is 64, plus 11 squared is 121. Minus 2 times 8 times 11. I know 8 times 11 is 88. 88 times 2 is 176. Cos 37. So C squared is equal to this. I can simplify this even more. 64 plus 121 is 185 minus 176 cos 37. And now I don't know what cos 37 is off the top of my head. I'm just going to put this into my calculator. So in the calculator, I'm going to put in 185 minus 176 cos 37, and it gives me this large number. I'm going to copy it down. So C squared is equal to 44.44015023. I haven't isolated for my C yet. I have C squared is equal to this. So to isolate for C, I'm going to take the square root of all of that. So 44.44015023. So I'm going to plug that into my calculator. So the square root of my answer, which gives me about 6.66. So I'm just going to write that here. C is 6.66634, approximately that. And we said we're going to round all side lengths to one decimal place. So about 6.7 is our final answer. So just a recap of what we did. We first determined what type of triangle it is. We said it's a non-right triangle. So we decided, okay, we then decided we need to determine which tool we can use. Sine law, cosine law or the 180-degree rule. So we looked for angle side pairs. There were no angle side pairs given. Here there's no angle, here there's no angle, here there's no side. If there are no angle side pairs given, use cosine law. If there was an angle side pair given, you would have used sine law. Okay, so we decide to use cosine law, but cosine law has two variations, one for isolating side lengths, one for isolating angles. We went for the side length because we were solving for the side length, and then it was just plug in the values and calculator work. Don't forget at the end, you're saying c squared is equal to a value, so to isolate for c, you do have to take the square root. Let's try this second question. So it says solve for angle C here. What type of triangle is this? Again, I have an acute angle here, an acute angle here, something here that looks like it could be 90 degrees, but it's slightly off, and we know it's not 90 degrees because we don't see that symbol there. So it's slightly bigger than 90 degrees. So we know that this is an obtuse triangle, once again. Again, it's completely random that both of these were obtuse. This could be an acute triangle as well. The rules would still apply. What tool can I use here? Again, you have to be given an angle side pair to use sine. So let's label everything first. If this is capital A, this is lowercase a. That's a 9, not a lowercase a, by the way. If this is capital C, this is a lowercase c. And if this is capital B, this is a lowercase b. So I'm going to look for angle side pairs. No angle here, no angle here, no angle here. I clearly don't have an angle side pair, so I can't use sine law, which means I'm going to use cosine law. Again, what's the reason? No angle side pair given. So again, remember, the general rule of thumb is whenever they give you an angle, make that C, or whenever you want to solve for an angle, make that C. In this case, again, C is the particular angle that we're solving for, so we don't need to manipulate this equation. In future questions, we might need to. So again, here I'm solving for an angle. There's two variations of the cosine law. This solves for a particular angle, so I'm going to use this variation. So cos C is equal to a squared plus b squared minus c squared divided by 2ab. Again, once you have the formula, all you're doing is you're plugging in the specific values. So a here is 9 squared plus b here is 5 squared minus c here is 8 squared all over 2 times a, which is 9, times b, which is 5. This, you should be able to do most of it in your head. So 9 squared is 81 plus 5 squared, 25, minus 8 squared, 64, divided by 2 times 9 times 5. So 5 times 2 is 10, times 9 is 90. I can keep going. 81 plus 25 is 106. Sorry, is 106, yep. And then 106 minus 64 is 42. So 42 over 90. Don't forget to copy this side. So cos C is equal to all of this, cos C is equal to all of this, and cos C is equal to 42 over 90. We can simplify this, so let's start by simplifying this. I'm just going to do it down here. So cos C is equal to, I can divide both of these by, I can divide it by 6 actually. So 42 divided by 6 is 7. 90 divided by 6 is 15. Okay, so I have cos C is equal to 7 over 15. Again, I haven't isolated for C yet. C is the specific angle. If I have cosine of C is equal to a ratio, again, the only way I can separate out an angle from the cosine is by using the inverse functions. So I'm going to do that on my calculator. So here's cos, the inverse would be shift cos. So the inverse cosine, and then I just type in my ratio in brackets. And that gets me 62.18 degrees. Again, we're rounding all of our angles to a whole number, so 62 degrees. So that means this angle here will be 62 degrees if these are the side lengths of that triangle. So I mentioned up here, you can use this law when two sides are given and the angle in between, or when three sides are given. Regardless, as long as you remember, if there's a side angle pair, I can use sine law, and if there isn't, I can use cosine law. That's the easiest way to figure out when to use the cosine law. So just like last time, we're going to solve a triangle question to apply the knowledge that we've gained. Okay, so in triangle ABC, A is 10 centimeters, B is 11.1 centimeters, and angle C is 68 degrees. Solve this triangle. So again, the triangle was not given to us. It wasn't drawn for us. So let's draw it ourselves. So I'm going to call this A, this B, and this C. And so this is lowercase a, this is lowercase b, and this is lowercase c. A is 10.0 centimeters. B is 11.1 centimeters. And C here is 68 degrees. Because it's a solving question, remember, we want to list out all the answers we want to have by the end. So I need angle A, I need angle B, I need angle C. I also need lowercase a, lowercase b, and lowercase c, so the side lengths. I don't have angle A, I don't have angle B, but angle C is 68 degrees. And lowercase a is 10.0 centimeters, lowercase b 11.1 centimeters, and lowercase c, again, something I need to solve for. So we have this triangle. Again, ask the same questions that were asked up here. What type of triangle is this? There is no indication that any of the angles is 90 degrees. So we are going to assume it's a non-right angle triangle. If it was a right angle triangle, I will give you some sort of indication that it's 90 degrees. Okay. So that's good. We know it's an obtuse or acute. It's just a non-right triangle. So we know there's certain tools we can use. We can use the 180-degree rule. So all three angles add up to 180. But that only works if we're given two of the three angles. We only have one, so we know we can't use that at this time. Then we look for, can we use sine law? With sine law, we will have an angle side pair. If I take a look here, I have an angle, but no side, no angle, no angle. So I have no pairs here. I'm going to have to go with cosine, the cosine law. Okay? With the cosine law, again, I'm going to keep repeating this. Always make the given angle C. So in this question, again, the given angle is C. So we're happy with that. If the given angle is C and we have A and B, let's take a look. So I have the angle, I have A's and B's here. I can solve for side length C. So because I'm given the angle C, I can solve for the side length C with cosine law. I'm going to use this first equation. So I'm going to write it out. C squared is equal to A squared plus B squared minus 2AB cos C minus 2AB cos C. Using the information, I'm going to plug this in so that I can eventually isolate for C. So here A was 10. Again, 10.0 and 10 is the same, so I'm just going to write 10 plus 11.1 squared. Notice I'm still putting it in the brackets. Times 10, 11.1 cos 68, which is equal to C squared. Sometimes the numbers don't work out. Like I expect you to know 10 squared, but not 11.1 squared. So you can plug this whole thing into your calculator if you need to. So I'm going to do that right here. So bracket 10 squared plus bracket 11.1 squared minus 2 times 10 times 11.1 cos 68. So I put everything in one step, and it gave me C squared is equal to 140.0473363. Again, I haven't isolated for C yet. This is C squared is equal to this. So to isolate for C, I'm going to take the square root of 140.0473363. So C is equal to the square root of my answer, which is 11.8341592. and we're rounding to 1 decimal place, so it's about 11.8. So I have my C here. I'm going to write down it's about 11.8, and I'm going to use fill that in right here. Again, it's centimeters because all the side lengths are in centimeters. So I've solved for this. Now I need to solve for the last two angles. So again, we're at that scenario where we use the cosine law and we have our side length C. What you should notice now is we finally have a pair. We have an angle and we have its corresponding side. So because we have an angle and its corresponding side, we can now use the sine law to solve, to continue solving this. Okay, so remember the sine law. So I'm just going to write it off to the side here quickly. So sine A over A is equal to sine B over B, which is equal to sine C over C. The pair I have here is my capital C and my lowercase c, and so I'm going to use this part of the equation. And we can randomly choose what we want to solve for first. So I'm going to say let's solve for A first. Okay, so we have lowercase a and the angle that we're going to solve for. So we need this part of the equation and this part of the equation. So I'm going to write that down here. I'm just going to separate this. So sine A over A is equal to sine C over C. Again, we needed to include the C's because that's our angle side pair. We randomly decide to solve for A first. We could have decided to solve for B first as well. It's up to you, but we decided A for this time. Okay, so let's plug in the information we have. We don't have angle A, so sine A divided by lowercase a is 10 is equal to sine 68 divided by 11.8. Notice that we did round here, so any answer we get from this point on is going to be a rounded answer, but that's totally fine. We're going to keep our rounded answer here. So now we have two fractions that are equal to each other. So we know that we can use the cross multiplication here, or use cross multiplication here. So on this side, we have 10 times sine 68. So 10 sine 68 is equal to, on this side, we have 11.8 times sine A. So 11.8 times sine A. Remember, I want to isolate for angle A, but I can't separate angle A from sine unless everything else is on the other side so that I can use the inverse of sine. So I need to move everything to the other side first, in this case, the 11.8. So I'm going to divide both sides by 11.8. So these cancel out, and I'm left with sine A is equal to 10 sine 68 over 11.8. So here I need to isolate for A. So before I do that, I'm just going to plug this into my calculator. So remember, you have a fraction. So when you plug it in, you want brackets along the top and brackets along the bottom. So bracket 10 sine 68 divided by, sorry, I pressed something by accident. So bracket 10 sine 68 divided by bracket 11.8. And that gives me 0.785749029 is equal to sine A. So we're at a situation where we have the sine of an angle is equal to a particular ratio. So now we can isolate for the A. So remember, you can never separate the angle from sine unless you use the inverse. And that only works if everything else, in this case, the 11.8, was on the other side. So I'm going to use the inverse of sine. So here's my sine. I'm going to use shift inverse of sine, and then I'm going to type in my ratio in brackets. 0.785749029, which gives me, so angle A is 51.790000745 degrees. And the angles, we are rounding to the nearest angle. So angle A is about 52 degrees. So I'm going to go plug in the new information I've gotten. So that's 52 degrees. And now the last thing I need to solve for is angle B. I can use another sine law, but I also know that these three angles will add up to give me 180. So the third tool that we have. So we're going to use that tool to solve for B. So we know that angle A plus angle B plus angle C is equal to 180 degrees. Angle A in this case is 52 degrees, plus angle B is up here, that's what I want to solve for, plus angle C, which is 68 degrees, is equal to 180 degrees. Now I'm going to simplify this, so 52 plus 68 is 120 degrees, plus angle B is equal to 180 degrees. So to isolate for B, I bring the 120 to the other side where it becomes a subtraction. And so angle B is 60 degrees. Again, that's an approximate value because our A was also an approximate value, so 60 degrees. And now we've solved the triangle. We've solved for every single length, sorry, here, and every single angle here. So I hope you're comfortable with this cosine law now. What you saw in this example is the cosine law really only needs to be used once, and then you'll always have a pair so that you can move on to the sine law. So hopefully you're comfortable with the cosine law. What made these questions easy is because I followed these rules and I made sure it was always respected. Always make the given angle C or the angle that you're solving for C. In other questions, you're going to be using different variables to name the triangle. So we're going to look at examples of how we can use those angles to rewrite these equations using the new specific variables. Okay, so just give me 2 seconds. Okay, so exercise, let's practice rewriting the cosine law using different variables. So as you just mentioned, the previous questions were easy. We had variables A, B, C, and I made sure that C was always the angle that was given or the angle that you're solving for. In other questions, you might see things like MKN or QRP. You need to know how you can rewrite these equations so that it includes these particular variables. So for the following questions, I'm just reading the rest. Do not solve for the indicated variable. I don't need you to solve for M or solve for P. I just want you to write down the cosine equation that you will use in order to solve for these equations. So the first thing I want you to do always is you still want to answer the questions that I have on the previous page. First, take a look at this triangle. There's an angle greater than 93. It's an obtuse triangle. Then you say, can I use sine law or cosine law? In this question, I specifically stated that you should use cosine law, but you should always check, okay? And so you know you're going to use cosine law. The rule I've been saying is that the angle that they give you should always be C. So here, this is the angle that they gave us. So the C is really our M here. So we know that our M is equivalent to the C in this question. So wherever you see a capital C, you'll replace it with a capital M. Wherever you see a lowercase c, you'll replace it with a lowercase m. Now, the A and the B really don't matter. It's really the C that you need to match up. So as long as your C in the equation represents the angle, in this case your M, your 93 degrees, you can choose any of the other two vertices to represent the other two sides. So what do I mean by that? Let's first label all of the sides in this triangle. So this is capital K. So this is going to be lowercase k. Again, I made it a bit more squiggly. Here is capital N. So this is lowercase n. And here's capital M. So this is lowercase m. In this case, I want to solve for a side length. So I know I'm going to use this equation. So if capital C, or if my C is equivalent to m, this C is also equivalent to m. So I have c squared is equal to a squared plus b squared minus 2ab cos c. Here, my lowercase c is going to be replaced with lowercase m. The a's and the b's really don't matter. So I'm going to choose k to represent my a here. It's a lowercase a, so it's going to be lowercase k squared plus the b is going to represent the other variable. So lowercase n squared minus 2. I said my a is lowercase k. My b is n cos m. So I just want to repeat what I did there. Essentially, the previous questions, I always use variables a, b, c. But regardless of what variables I use, you need to be able to figure out the cosine law. So the only thing you should remember is the angle that's given, or the angle of interest, should always be your C. And I'm saying C in quotations. So the M here represents our C. So wherever I saw an C in the equation, I replaced it with an M. The lowercase c was replaced with the lowercase m, and the capital C was replaced with the capital M. You can choose either of the other variables to be A or B. Those don't matter as long as the angle was your C in the equation. Everything else will fall into place. So I chose K to represent A this time. So every time I saw a lowercase a, I replaced it with the lowercase k. And I chose N to represent B this time. So every time I saw B, I replaced it with the lowercase n. Could you have chosen N to be A and K to be B? Yes, that's totally fine, and it would give you the exact same answer. So as long as the angle matches up, the angle given is always your C, this equation will always work. So I want you to try this on your own using the same principles that I just said. I want you to try it, pause the video, try it, and then come back and then check your work. Okay, so this is essentially what your answer should look like. So what I first determined, again, it's an acute triangle. I saw that I didn't have an angle side pair, so I knew I had to use cosine law. So I labeled all the sides. Capital Q gets paired with lowercase q, capital P, lowercase p, and capital R, lowercase r. Then again, I said I want to determine a side length, so I know I need to use this equation. I also know that the angle that was given was P. So my C is going to represent my P here. So I replaced my capital C with the capital P and my lowercase c with the lowercase p. The other two, it didn't really matter. I decided to choose R to be my A. So my lowercase a's were replaced with lowercase r. And I chose Q to be my B's, so I replace my lowercase b's with lowercase q's. Some of you might have gotten this answer, so Q squared plus R squared minus 2QR cos P, because you chose Q to be your A and R to be your B. It doesn't matter. These both mean the exact same thing. They will give you the same answer when you solve for it. Let's try this one. Again, it's the same deal, but I want to determine an angle this time. So this is my angle of interest. Again, I told you to use cosine law. So when I know when I'm trying to determine an angle, I use this formula. So I'm going to copy it down. Cos C is equal to A squared plus B squared minus C squared over 2AB. And this time, again, follow the same rules. The angle of interest should always be your C. This is the angle I want to solve for, angle Z. So I know Z is equal to C. So I'm going to go put in my lowercase letters before I make any sort of changes to the variables. So this is capital C, so this is capital Z, so this is lowercase z. This is capital X, so this is lowercase x. This is capital Y, so this is lowercase y. So I know that my C is just being replaced with Z, so I'm going to replace the capital C with capital Z. Again, I can choose A and B to be any of the other things. I'm going to choose X to be my A this time. So X squared plus Y is my B, Y squared minus C. I already said C is Z, so this is a lowercase c. So I'm going to replace it with the lowercase z. Divided by 2, I chose X to be my A and Y to be my B. So exact same thing that we did for the previous two examples, except for we're using the second version of the cosine law. We're using this version instead because we want to solve for an angle. So I want you to try that here. Again, pause the video and then tell me what your answer should be. Okay, so you should have gotten one of these two answers. So I labeled my side length. So this is lowercase d, lowercase e, lowercase f. I know I want to determine angle E, and what I said was whatever angle you are given or you're trying to determine, that should always be your C. So I replaced C with a capital E here, and so the lowercase c I replaced with the lowercase e, and then I randomly chose D to be my A, so I replaced my A's here with D, and I chose F to be my B, so I replaced my B's here with F. And that was it. If you had chosen D to be your B and F to be your A, you would have gotten this. Again, it represents the exact same thing. So using this information now, I want you to solve this triangle, try it on your own, then try the homework, and then submit the questions to me. Thank you. On the Google Classroom. Thank you.